We'll do another one. All right, so we're doing number 12 right now. We already annotated it. We already set this up with the information from the story, and now we're going to solve it. So one way to solve a system is substitution. So I can take the top equation and substitute into the other. Another one would be elimination or graphing, but the easiest way is to recognize both equations are equal to y, so we can take them and make them equal to each other. So take the top equation, substitute it into the bottom equation, and now we have one equation, one unknown. So the next step is to distribute. So make sure you don't make the mistake of not going 60 times 3. And then it's a simple linear. Can you combine like terms and solve? So I'm going to subtract 36x. I'm also going to add 180 to both sides. So I end up with 180 is equal to 60 take away 36 is 24. And then the last step is to divide. Do you think 24 goes into 180 evenly? I don't know. So I don't think it goes in quite evenly. So it's 7.5? Is that right? So do you know what I did first? Because I didn't have a calculator. What's the number I thought of first that went into both evenly that was easy to work with? Was 6. So 6 goes into both. And then 4 goes into 30. How many times? 7. With 2 over 4 left over. So that's 7.5. So what is the time in hours Perry drove before? And remember, x is what I was looking for. If I wanted to know how long Jessica drove for, what would I do? 7.5 take away 3. That would give me Jessica's time. But I'm looking for Perry's time. So how long did Perry drive? So Perry drove for 7.5 hours before Jessica caught up. All right, let's look at number 14 when you're ready. So, a jet flew to Jakarta and back. The trip there took 6 hours, and the trip back took 5 hours. What was the jet's average speed on the trip there if it averaged 222 kilometers an hour on the return trip? So first I'm going to annotate it. So I have 6 hours, I have 5 hours, and I have the jet speed to be 222. I know that the question is, what was the jet's average speed on the trip? There. So I'm going to create a little chart to organize the information. So I understand that distance is equal to rate times time. And we have the trip there and the return trip. So what I do know is the trip there took 6 hours. So underneath time, I can put down 6. And the trip back took 5 hours. So I can put that underneath time. I know that the jet's average speed on the trip was, the average speed on the return trip was 222. I don't know the trip speed there. That's my unknown, right? And then what do I know about the distance? If you went somewhere and came back, that whatever the distance is exactly the same. So now we have two equations. One equation is y equals x times 6, and the other is y equals 222 times 5. To solve this, I can take one equation and plug it into the second one. Because they're both equal to y, I can make them equal to each other. 222 times 5. Is that okay? Like 2 times, do you see 200? So 200 times 5 is 1,000. 20 times 5 is 100. And 2 times 5 is 10. So it's 1,110. And then the last step is just to divide by 6. It actually goes in evenly. 185. Does it make sense that the plane was going slower on the way there because it took more time? So it makes sense it's less than 222. So the jet's speed on the trip there was 185 kilometers per hour. All right, number 16. Now I have to just hold back just for a moment. We've done 3 in a row together. I've done them for you. Now I need to know that you're like focused in here. So number 16, I need to give you a chance. So I need you to read it and see if you can organize the story and see the polynomial equations that's coming out and to be able to solve the simple system. So do you feel like you've done questions like this before and it's just a review? Or is this brand new? Brand new. Do you know if you're on Alex, do you know questions that you've seen like this? Yeah. Sometimes Alex explains things really complicated. I don't like explaining things complicated. So again, I'm just walking around to give you time to read it and annotate it. Can you set it up? Do you find it helpful to have a little chart to organize the information first? And then go from there. It's okay. No harm, no foul. So what number in the story has nothing to do with the mathematics? What number? 26, right? No, nothing to do with it. Good reader. So keep working. I'll do some stuff, but when you're ready, you can look at the screen. So if you haven't had, I'm not going to keep going. I want to make sure you have a chance. But did you annotate it? The most important part of the annotation is the question. Like, what are you actually looking for? Your goals, and then the other parts help you get to what you underline. But to understand, see if you can set this up and see what the two equations are before I do. And what I do is I start with what's simple. Like, what's direct that I know? Like, when something's like something faster than something else, that's not direct. But is there anything direct that I already know? That's direct, right? They have the same distance. It would take just a little bit of reading, but if you read well, you'd understand the time. Like, the time is really simple if you're reading well. Did you see that? Like, the time is not unknown. I know exactly how long the ship was out there for. Did you know that? And I know exactly how long the submarine is out there for. So how many hours was the ship been out there for? Okay, how many hours has the sub been out there for? 10. How many hours has the ship been out there for? 11, right? 1 hour later, right? So if the sub has been out there for 10 hours and it left 1 hour later, then the ship must be out there for how many hours? 11. They've covered the same distance, and what we know is, this is what I'm looking for, right? The ship's average speed. We only know that the sub is going how much faster? So if the ship is going X, then the submarine must be going X plus 2. So take a moment and write down two equations. So when you read that, can you see how this chart organizes this story? Each part. This you needed to be a good reader. However fast the ship is going, the sub is going 2 miles per hour faster. Just add 2. Now, two equations and solve them. And then can you write a nice concluding statement at the end that finishes the story? Thank you. You're welcome. So, one equation is y equals 11 times x, and the other is y equals x plus 2 times 10. If I make them equal to each other and distribute, you get 11x is equal to 10x. And don't forget the 20, right? Do you know where that comes from? So when you subtract 10, guess what? The answer is really simple. What is x equal? And then what's the answer to the question? Find the cruise's average speed. If the question was how fast was the submarine going, the submarine was going 20 2 miles per hour. If the question was what distance was covered, right? How many miles was covered? You could plug 20 in and realize 11 times 20 is 220 miles. You could answer different parts of the story, right? Whatever part's being asked. All right, when you're ready, turn the page. All right. The next group of questions are called mixture problems. So at the beginning, we did work rate problems. Then we did what are called dirt or distance rate time questions. These are called mixture stories. And so again, we're going to organize this with a chart to help us with understanding what's happening and be able to solve what's happening. Now, when you see the word alcohol in this case, I need you to think of a chemistry situation rather than a different situation. So in this sense, it's a chemistry situation in terms of what the word alcohol means in this sense. So, and do you know what QT represents? Right. So it's not how, right. So 5 quarts, right? So 5 quarts of an alcohol solution was mixed with 1 quart of 51% alcohol solution to make a 31% alcohol solution. Find the percent concentration of the first solution. And the key here is we're going to take the quantity times the percent, and we got to make sure the percent is a decimal. So we have how many different solutions here? We have 3 of them, right? So we have solution number 1. We have solution number 2. And then we have the end solution, right? And the 2 things that we're looking at is the quantity, how much we have of it. In this case, the quantity is in quarts, and the percent in terms of the solution. What happened? Oh, look at my camera go. Oh, it's slowing down. Now, for these questions, we actually don't have to write it as a decimal as long as we're consistent on both sides of the equation. And I don't know why my camera's slowing down. Isn't that weird? All right, you ready? Let's just see. Oh, there we go. So for solution number 1, do you know how much quantity we have? 5 quarts, yes? Do we know what the percent was of alcohol? So that's an unknown, right? For solution number 2, do we know how much we mix there? No, we would mix with how much? Sorry, we know, right? How many? 1 quart. So that means the end solution will have how many quarts? What was the percent solution for the second one? 51%. what was the percent solution for the end? So we don't need to write this as a decimal as long as we're consistent on both sides, and it'll be easier not to write it as a decimal. So how we're going to set this up is pretty simple. We're going to multiply the quantity and the percent. So we have 5 of a certain percent, then we're mixing it, and when we mix it, we're adding to it, right? And the other one, the quantity is 1, but the percent is 51. And then the end solution has how much? 6, and what's the percent? And that is the equation we're going to solve. So I have 5x 1 times 51. Do you know what 6 times 30 is? And then 6 times 1 is 186. Subtract 51. That's 135. That obviously goes in evenly. How many times does 5 go into 135? Be 20-something, right? 27. I agree. So the question is, find the percent concentration. So what's the percent concentration of the first solution? 27. So the first solution is 27% alcohol. So again, this is called a mixture problem. Have you ever done a mixture problem before? Sometimes it's a chemistry type situation. Sometimes it's like coffee. Sometimes it's nuts. Sometimes whatever it is that you're mixing, right? Sometimes they're mixing a punch or something like you're drinking at a whatever. So here's a situation where you have a fruit punch. Same idea. It says, how much of brand A fruit punch, 20% fruit juice, must be mixed with 3 gallons of grape juice to create a mixture containing how much? 40%. Now, to start with, we write down, what are we mixing? So what do we start with? So first we're starting with brand A, and then what are we mixing with brand A? Grape juice. And then at the end is your end mix, right? And the two things I care about again here is the quantity, and it's again the percent. So if you read carefully, do we know how much we have of brand A, or is that the question? So the quantity of brand A is my question, isn't it? What's the percent of brand A of fruit? 20. Next, grape. How much do we have of the grape juice? How much? 3 gallons. And what percent of the grape juice is juice? What percent of the grape juice is juice? It's grape juice. The whole thing is juice. It's grape juice. So the percent of the juice is 100 because it's juice. It's grape juice. So we're talking about percent of juice. The whole thing is juice, right? So it's 100%. Now, the end mix. If I don't know how much is in brand A and I add it to the grape juice, how much is my N mix? The quantity of it would be X plus 3. And then the N mix, what percent do I want to have? So, to set up the equation, we multiply the quantity and the percent. So 20 times X plus 3 times 100 is equal to X plus 3 times 40. See how we set up a chart to organize the equation to make this easier. Then we're going to distribute, combine like terms, and we're going to solve it. Make sure that you choose to distribute properly. So that's 40x plus 120. Make sure you combine like terms. So I'm going to subtract 20x, and I'm going to subtract 120. Are you guys talking about the math over there? Yeah. Nice. I like it. Perfect. Then we divide by 20, and our answer is, the answer is 9. So the question is, how many gallons do you need of brand A to get a 40% N mix? And the answer is you need 9 gallons. I'll just put the N part right here. You need 9 gallons of brand A. All right, one more to do. One more. This one I want you to try your best to set up. So I want you to read it. The word saline. Does anyone know what the word saline means? Saline is a fancy way to say it's salt water. So saline means it's water and salt. Saline solution. Got it? Salt water? So read number 22. The ones that we did not do is your homework, so you can practice it so you do well in the quiz tomorrow. Correct. And not just this, right? It's on stories, right? Work.
Work.
Don't yell at Kimberly. Tell her she's not the boss. Thank you. All right. That's what I hear my... All right. Number 22. All right. Settle it on the volleyball court. So, 22. I like this competitiveness. We need that tonight, right? Who are we playing tonight? That's it. Let's go. Oh boy, that's a kiss, right? Yeah, right there. Easy. That's a jinx and a half. So, 22. Please read it. Can you organize the information and see what polynomial equation comes from it? I did that twice, Corey. I'm sorry. So, I'm going to separate. I started?
Yeah, you
Don't take responsibility. So, 22. Someone's going to sit beside me in a second. 22.
Not it.
Yeah, not it. Like you're the boss. 22. See if you can organize and do a mixture question. Again, on Alex. Let's do this weekend. All the topics. There's like whatever there is, right? Sir. What's that? I do. So we're going to, right here. So let's look at 22, and then we're going to look at the next story packet I gave you. So first I look, what am I mixing? So I have a saline solution that's being mixed with a 5% saline solution, and then we have an N mix, right? And so when I break this down, the two things I care about is the quantity and the percent of salt. Not yet. Someone's there. Okay. So you have to wait. Let's do this question first. So when I look at it, how much do I have of the saline solution? We have 2 milliliters. And it's being mixed with a 5% saline solution. So 5 milliliters of a saline solution. That means the end mix will have how many milliliters? Right? Now, I don't know the percent. I don't know the percent of the first solution. The second one, it's already there. What's the percent? 5. And then I want my end mix to have what percent? 15. So there's your setup. So we have 2 times x plus 5 times 5 is equal to 7 times 15. See, once you organize the information, the equation that you get out of it is simple, right? The work is the structure, right? The organizing part. So I have 2x equals 25. Any idea what 70 and 35? That's 105. Subtract 25. So that's 80. And then divide by 2, and it's 40. So the question was, what's the percent concentration of the first solution? So the first solution is 40% saline. So there are questions you need to practice. I'll do a homework video on this. So I'll do a homework video on this so you can practice with me. All right, there's the answer right there.